Welcome, episode 10. I'm thinking today is going to be implementing the collision detection that we did last time, but into some logic. And then other things I was thinking of is I don't like how my sprite, where do I do the animation? Here. I don't like that I have to add this X offset separately. It's not a big deal, so maybe I'll just leave it, so I don't know. But let's refresh a little bit on how our logic is working, because in order to do the logic for our collisions, we need to kind of understand how it's working. So there's a part, I've got the ostrich clamped so it can't go above the top of the screen. So I think I have that right here. I'm saying, I noticed last time it was maybe a bit too much of a bounce off the top, so maybe 0.8 is the dy we want to give it. So gosh. So yeah, right here, we're saying if we're in the air, then our dy gets modified by gravity, scaled by time, scaled by delta time, which is delta time is a constant. But yeah, I guess that means that it'll be a constant fall instead of speeding up. Is that right? Like it doesn't. No, I don't know. I really don't know. Like, let's see if he kind of falls faster. It's hard to tell. Oh my god. Oh god. Oh my gosh. Wait a second. I could have sworn I just changed my dx when I was in the air, which I thought was impossible. Oh no. Gosh, that's another thing I gotta implement. This game is really tricky. So, yeah, if I'm it's like if my speed tier or my dx is moving right, if my speed tier is moving right, facing left, if I just flap, I'll keep my dx. See that? Oh my gosh, it's tricky. So I'll keep my dx. Wow, and then it turned. it turned like after a certain amount of time, I guess. Because I'm just flapping. Gosh, and then it's tricky. So, yeah. So I keep my, I keep my DX if I'm just flapping, but if I'm in the air and flapping and then put an input, it slowly changes my DX. Which is wild. It's really complex. That's something I did not know. Let's add that into our notes. Change DX slowly if in air and key is down. That's really tricky. But that's really cool. That's the sort of interactivity that is like subtle. Because it's like, I mean, that's great because if you're in the air and you're about to like land in some lava and there's some enemies there, you want to be able to change your direction. But if they're flying towards you, you can only change your direction so fast by spamming that jumping while that other input is held. So I feel like it's pretty damn balanced. Why did I check? Oh yeah, I was checking. I think the gravity is okay. If I'm noticing that gravity is messed up, I'll come and fix it. But I think in our play state, we should do all this collide logic. So maybe we start with the left and right. Because my reasoning is the top collide's going to be easy. Bottom collide's not going to be easy. Because as of right now, our Y position is clamped to the ground logic. Or yeah, our Y position is clamped to the floor of our level when it should be clamped to the floor of whatever collidable it's interacting with. And then also my Y is clamped to that ground level instead of any platform, any collidable. And I'm only applying gravity when I'm in the air. That means I'm not going to be able to detect a collision if I'm on a platform and I walk off of it. Because it would never collide. It would just say, yeah, it would never implement gravity because it would think I'm still grounded. Because the collision is not getting detected or the no collision is not getting detected. So that's why bottom collides is going to be the trickiest. So I guess the question is, do we put our collide functions in the ostrich class? Which I think we do. I was thinking we need to put it in the play state, but we need to update player one's info based on whether or not the collision was detected. So I think it needs to be in the ostrich class. So maybe after our input handling, Gosh, that's a lot of input handling, homie. Yeah, maybe after our input handling, that's when we put our collide logic. And we're going to say something like, if self, let's do the top collides first. If top collides with a platform. And the other thing is we got to make this scalable. We don't only want to check if it collides with a platform or with platform 1. We want to see if it collides with any platform. So at some point when we have more than one platform, we're going to have to make a table of collidables and then loop through every single collidable and check for the collision that way. So for right now, we'll just do the platform 1 because that's the only platform we actually have right now. But if this top collides gets true, then we're going to set our self dy to that +8. But that's not only what we have to do, because if here's the platform, here's the ostrich, if my dy is a low enough number, I'm going that in the one frame update, I'm like inside the platform here. It'll give me the dy of 0.8. But I would still be colliding, so we need a reset. Like, we don't want it to be clipping inside the platform. So once we detect the collision, we need to set the dy to 8, but also move our ostrich y. Self y gets whatever the platform 1 y is plus its height. And then this dy being 0.8 is the same amount as our bounce off the top of the screen right here. And then here we reset our value before we give it dy, which I don't think is totally necessary, but it can't hurt to stay consistent. Yeah. Let's see if that top collide. Oh gosh, that's not what I wanted. That's what I get for doing the arrow keys in my terminal. Okay, let's see if we bounce once we hit the top. Yeah, buddy. Okay, then we should. Yeah. And then maybe we give ourselves a little leeway. Well, let's see. Because, yeah, that should collide too. Okay. Shoot. You guys, why? Once again, this one is busted. Like, I should be able to, I can stop, but if I'm stopped, wait. So I guess my question is, if I'm stopped and then I input the other direction, do I automatically start walking or do I just turn? Um, yeah. Wow, and there's like even a slower. That's pretty amazing. Like instead of there being 5 speed tiers, it's on a scale. Because look how slow that is. And that's only when I tap it as little as possible. Um, okay. So, just curious. Yeah, because I just can't get it consistent. Like, I'm, no, um, like I'm trying to just, well, so what I'm doing is seeing if, shoot, if I'm so like I'm in speed tier 1 and I'm just alternating left and right, and instead of stopping, like, well, I guess it depends how fast. Yeah, it depends how fast I press it. Yeah, it's just a little janky. But I do think instead of 5 speed tiers, I think it's instead of 5 speed tiers, it's on a spectrum. Like it isn't 5 different speeds. I think it's a single speed that gets faster and faster up until a max speed, and the animations are tethered to that speed, so it's not just 5 speed tiers. So I'll probably want to fix that, right? Because it's not. I don't know. It's like, at what point is it good enough to be, remade Joust? Because it's like, I think I should probably try to implement it that way because I really like when if you tap it as little as possible, he walks like really slow, like slower than my current speed tier. My current speed tier 1 animation, I should say. But um we got our top collision working. Let us see if we can do our right and left collide, which should just swap our dx. And we swap our dx based on our facing direction, because right here, if I'm facing right, then my speed tier is positive. My dx is positive. But if I'm facing left, my dx is negative. So if we just switch this flag upon right and left collision, then we should be able to keep our speed tier, meaning keeping our same dx, just reversing its velocity. Yeah, same number, but, negative or positive. So, where's our collide logic? Right here. Let's do if our ostrich left collides with platform, then we are going to set our x to be, so if the left collides, we need to set it to the rightmost side of our platform, which would be our platform's x plus its width. And then we also need to swap our facing. So if we collide left, so I guess here's the next question. If we're colliding left, do we have to be facing left? No. We can collide left facing right if we're in the air. Oh, you know what? Yeah, and that screws us too. Because in the air, our dx doesn't get... This is so complicated. This game is amazing. Because right now our speed tier... Gosh, where is it? Right here. Our speed tier is only... Or our dx is only swapped if I'm grounded. Which we need to say... We need to... Because, yeah, right now, if we say, hey, give us a... Or if we say swap our facing direction, it will swap our facing direction, but it won't change our dx. So maybe we can do some trickery like... Well, that's getting really confusing for me. I was going to say, like, we should just do, if left collides, that means we're going to be now having a positive dx. So maybe we just say dx gets... Yeah, we need a... It's like we need a corresponding... It's like we need a corresponding one of these code blocks, but for when I'm not grounded, but when I'm also left colliding, because we don't want it to shift our dx when we're just in the air. We only want to shift our dx when we're in the air and we're colliding. So does that mean we add another one of these code blocks? Because we need to tell it what speed dx is getting, because it needs to get its same dx, just the opposite direction. Also, maybe we say... So you can't skid in the ground, so that's a little... We wouldn't need that. So maybe we say, if we're not grounded, well, fuck. We also got to switch our dx if we are grounded and collide with something on the left. Because if there's two ostriches on the floor grounded, they like bump and turn around. This is tricky, man. So maybe let's just try. Maybe let's just try it and then we'll see what cases we're omitting or whatnot. So right now, if it left collides, then we're going to set it to be facing right. Well, yeah. If it left collides, we're going to reset its position to, you know, just so that they're not touching. And then set facing right to true. And then this facing right to true will, once I'm if I'm grounded, then this will make it so that my dx gets reversed. But we need to do it. We need to also, like, we need to do that, but we also need to do it if it's in the air. But if we're in the air, just swapping that facing right boolean is not good enough to shift our dx. So let's see. Let's try to do the air one first, because I think that's the trickier one. Then we can worry about the simple one. And because we don't have any collidable objects that would be touchable when grounded. So since we can't test that at the moment, I think it's best to try the in the air one. So if we collide on the left and we're in the air, then we are going to set its x position and facing right, but we're also going to give its dx a positive value. So is that enough? Because the way assignment works, I'm pretty sure. So it's like, for you, if you aren't too familiar with programming, this equal sign is not equals. This is the equality operator, equals. What this single equals is called the assignment operator, and it moves the values from the right into the left. So we're saying, that's why I say gets all the time, because it's better than saying equals, because it's not testing for equality. I'm saying self dx now gets the absolute value of whatever its dx was, which, if we're colliding left, our dx was a negative. So then we're setting it to a positive, but I'm not exactly sure that'll work, because I'm just trying to think. My dx is positive. Well, let's see. I mean, I don't know why it wouldn't work. I'm just like, I'm just imagining problems. So we're going to be moving left and colliding on the left. That's it. Oh, well. See, look at that. Since we don't have the top collision, it just gets busted. Wow, look at that. That's sick. And if we're under, we're just going to bounce. But if we're nice. And then if we hold left, yeah, skid. Cool. That's sick. That's sick. Okay. So this is, mid-air left collides, but we also need to do a grounded left collides. which we can't really test just yet because there's nothing to collide with when you're grounded. But we can, we can add that. I mean, we know what the logic is going to be, right? It's going to be our function with the collidable and grounded. And then it's basically the same thing. We just don't need to reverse our dx because when we're grounded, just swapping our facing right Boolean will take care of that, I think. So we're setting our x to the rightmost part of the collidable. Not what I wanted. And swapping our facing right Boolean, which should change our dx. So I guess now I'm thinking like why thinking this is unnecessary now, but like, is there, like, I'm thinking that we don't even need to check if we're grounded. We just need to swap its dx. So yeah, I'm thinking this is actually redundant. Like, we don't need to even check if we're grounded, because if we are grounded, like what I'm saying, if a left collide is true, we know we want to reverse our dx. So this will give us a positive dx, because anytime a left collide is true, we want a positive dx. Yeah. So we shouldn't even need to check. Shouldn't even need to check if we're grounded or not, and that'll take care of the grounded left collides as well. I'm pretty sure. Let's see. Okay. Okay, so that still works. So I'm thinking it'll work the same if I'm grounded, so maybe we don't even need that. Then we need our right collides. We will need to set our leftmost, or no, our rightmost position to the leftmost position of our collidable. And then face left, and then swap our dx to negative, which we're just going to say self dx gets negative self dx now. Let's see if right collide works. U267 right here. Oh, self. We're saying our self.x gets set to be the platform X shifted by our self.width. Is that right? Not what I wanted. Nice. Okay, sick. Oh, see, it detected a right collision there. So once we get the bottom collision logic. So yeah, it keeps our dx, just flips our dx. And then if we're grounded, it should do the same thing. Nice. So let's do our bottom collides. Okay, yeah, this is the one that isn't going to be beautiful. Well, you know what? Maybe we don't have to apply gravity every single frame we're on a platform. We can just, because we have to check. It's so tricky. Because I was going to say, like, hey, we can just. Oi, oi, oi. So if we detect a bottom collision, we say, okay, your Y is now clamped to the top, to the top of the platform there. But then if I'm walking off the platform, how do we trigger that we're not on a platform anymore? I think we really do have to add gravity every single frame. Is that really the case? Is that really the case? If we don't want to add gravity every frame, then we need a way of detecting whether or not the frame, we need to detect. So maybe instead of a collides function, we have a check for ground function. And we're looking if, yeah, no, shit, how do we do it? Yeah, how would a check for ground function work? We would say like, hey, what's ostrich's xy, and then we need to say, is there a collidable object right beneath it or not? So how would it would take, yeah, we would take a check for ground. So if we write a function called check grounded, and we're saying it takes in a collidable. So we're going to say ostrich colon check grounded platform 1. It'll see if said platform is right beneath the ostrich, and if it's not right beneath the ostrich, then we need to add gravity again. So I guess the question is, how do we lock? I guess it's like the ostrich's Y position is locked to the top of whatever its last collided ground was, Y, unless up is pressed, or space. But I think we can do something like that, and then we don't, because yeah, my gut tells me adding gravity every single frame for every single ostrich is just a waste. You know, because if we got four enemies on screen, one ostrich on screen, then we're gonna be updating, you know, 6 different characters by gravity, maybe unnecessarily every single frame. If they're all grounded, we'd be doing all that calculation unnecessarily. But then if we do the check grounded, you know, we're asking on every frame, hey, are we grounded? And then if not, keep its dy. So isn't it just the same amount of work for the computer to do? This is really tricky. So I think I just need to make a decision and go for it. So it's like, I think we might as well just add gravity every frame. Check for, we'll see. Let me write some of this out real quick. Or maybe I'll write it out here so you guys can see it too. So basically, and then so if we go the add gravity every frame route, we need to add gravity, check collision, if true, reset Y position. Then if we use our check grounded function, we need to it would do some math to check if platform directly below which is similar to collision, but they're not actually colliding, so it's a little bit different. Then we need to check if platform's directly below, then if not, apply gravity. And then if it is, then it just needs to continue its Y being clamped to the last Y of its collidable. Okay. So I'm thinking this grounded function is probably going to be a little more streamlined than adding gravity every frame for every instantiation, even though we have to check for the platform on every frame. That's less work than applying gravity and resetting it if we're grounded. So I think that is the way to go. it's not as easy as just writing my if bottom collides function, because my self.y up here is on multiple levels set by a hard-coded ground level. So I'm still thinking of how to change that. Like, it's like if I shoot. I really, it's tricky to implement, because we need to somehow say, oh, you know what? No, yeah. If we do our check grounded function, our check grounded function is what tells us what our ostrich's y needs to be clamped to if it's grounded. So instead of self y being this, it'll be if ostrich, check grounded, meaning there's a platform beneath it, then set its y to the said object that is grounding it y. Yeah. Still a lot of work, but I think it can work. And I think that's the way to do it. However, I am watching my friend's house this next week, and I got a trip to LA that next week. All that to say, I'm going to try to wrap up today's episode, and I'm going to try to stream and post as much as I can. I think I'll be able to post throughout this next week. But as soon as I go to LA, it's just going to be too much work. So I think that's only going to be 3 or 4 days. But I'll be taking my programming books and reading that. Let us see if we can merge our Git branch. Yeah. Commit with a message saying added collision logic, not just detection, collision logic to sides and top. Git push original joust. Git push to our remote repository original joust. Okay. Let me how to merge branch git. Here. Let's assume you've committed your changes. Switch back to your master. And it's not master, it's main in my case. So I would do git checkout main. And then I would wait. Okay, so look, merge the hotfix branch back into your master. Do this. So we'll need to be on our main branch. Then we'll say git merge. Okay, that's easy. So let's do git checkout main. and then git merge original joust. Now, did it work? There was no... Wow, look at that. 443 line difference in ostrich. Oh, well, yeah, we took him out of play state, so it's hard to say. Does that mean... So now that I'm in git joust main, okay. Now let me see if my main joust repo main. See, that shouldn't be. Original joust had a push 3 minutes ago. I think I need to commit. And say merged original joust into main. And then see, look, my branch is ahead by 27 commits, so I gotta push it. Okay. So now if I refresh this on my main branch, it should have all my fixes. Yep. Yep, 4 minutes ago. Okay. Okay, so I'm on my main branch now. Wow, look at this, 41 commits. This is cool. Okay. Now we're on our main branch. Cool. So, you know, the whole goal of this channel is just to help me program more often, help me stay committed to even just a little bit of progress every day. I think it's been a huge success so far. We've got left and right collision, top collision, and I think I have an idea how to fix our not only bottom Y grounded problem, but our that's a big problem. So yeah. Hey, thanks for watching. Stay cool. I don't know.